is what we want. When so you must be thinking that we can use general group by query and we can do this. Okay. So first of all, yeah, I think we looked into it. So this is how we have done. So what we are doing here is we are using start time of the first log, okay, and end time of the last log, and we are summing up the miles. If you check the aggregated functions which are available in PostgreSQL, so there are there are no default function for finding out the first in the group and the last in the group. This is a group. There is no function to find out that. Okay, what we have done is on PostgreSQL wiki site they have provided the documentation how we can add the function aggregated functions first and last. So for the demo purpose I have already added that functions into the database. Okay, so what if we use directly group by query on this table? So this is a general group by query, so we are grouping based on the state. Okay, let's see how it works. So what we are doing here is we are using ID of the last record, okay, while retrieving, and we are retrieving last state. So it doesn't matter whether it is a last or first state, because it would be same, because we are grouping based on the state, so it would be same state. Okay, for the sake of convenience I have taken just last, and we are taking first start time of the first log, end time of the last log, and summing up the miles. Okay, are you clear with this query? Oh. Okay.
Is it readable?
Yeah, great. So let me run the database. Yeah. I think I need to increase font, right? It is really small too. Check it. I think it didn't update, right? Okay. Okay, display settings. Where is this? Okay. Okay, this is fine. Okay, if I have already populated the database table, so let's see. Okay, these are the records. These are the same records which I showed on the slide. Okay, so I'll run this query here. See, so what it has written is, it has written only 3 records for each state. Okay, on duty, what it is saying that the driver was on duty from this time to this time, but it is not the truth. Driver was not on duty, because in between driver was off duty, driver was sleeping and all. Okay, so to generate, so directly using group by query is not helping us to finding out the sequentially group records. Okay, so how can we solve that? So first thing is that when we use group by, it groups the unique values in a column. Okay, so we decided that we should generate a unique value for each sequence. Okay, for each sequence we will generate a unique value. So directly, without using directly group by query, we will customize that query to use subqueries. Okay, we will go step by step how we have customized, how we have used the subqueries. Okay, first of all, we need to know the sequence has been broken. Okay, whether the state has been changed or not. So we will generate one virtual column, which would be we can name it as group flag. Okay, that column will tell us that whether the sequence has been broken or not. Okay, so here what we are doing is, are you familiar with the function lag over in PostgreSQL? So actually the lag over function, what it does is, we are using it in sequence, in a sequence of the start time. So what it does is, lag means it checks the previous record. It checks the previous record of the with reference to the current record. Suppose there is a first log called on duty and second log is off duty. So it will check, if we are checking off duty log, second log, it will check the state of the previous log. So what we are doing here is just we are checking whether the last state and the current state are same. Okay, if the last and current state are same, we are returning null, and if the last state and current state are not same, we are returning 1. That is the simple thing we are doing, and we are naming it as a group flag. So I'll run that query, so you will have idea what it is returning. See, here there was no previous record present, that's why it has written 1. Okay, the state is same, it has not changed, that's why it has written null. Here state has changed, it has written 1. Here is the same thing. Done. Okay, so how we can use this for generating a unique value for per sequence? So now we are going to do a cumulative sum of this group flag values. Are you familiar with the cumulative sums? Like summing up the second with first, then third with second, and like that we are going to continue. But we need to define the sequence. That's why we are remember that we are using a start time sequence. Like we are ordering all the records based on the start time, because we need to know when the driver was on duty and off duty based on the time what we say time axis. Okay, so now using this we will generate a unique value per sequence. Here what we are doing is, we are doing a sum of group flag. So this is the syntax for doing a cumulative sum. Okay, sum over order by this order, we will generate a unique value, and we'll name that column as unique sequence value column. Okay, so this is the same query which we just run on the console, and this is the new query which we are using in outer context. Here, just we are summing up the values in the group flag. Okay. Yes.
So like in lag finds the previous row, right?
Right.
So what will happen in the first row?
Yeah, it will return 1 because there was no first row present.
So the state will be like lag, that there will be null.
Yeah. Got it. And remember that sum over function, it is like that sum function in the PostgreSQL or SQL, it ignores the null value and it directly sums up the available values. Okay, integer values. So we'll run this, so you will come to know. See, this is the group flag which we generated before, and this is a new column. So what it has done is it has summed up 1 with null, so it has written 1 1 1, and it has summed up with this 2 3. So if you check that, we are having a unique value for each sequence now. Okay, so we can use now group by. So the purpose of state column is done. It is no more needed for grouping. Now we have another column which we can group, and based on that we can generate the unique sequence log. Okay, so this is the final query, which looks like this. Okay, this is our first query, which is related to the group flag, generating group flag. This is another query which we used for generating a unique sequence value. Okay, and this is the outer query on which we are using group by. So what we are doing is we are just retrieving last ID, last state, first start time, last end time, summing of the miles. Okay, and group by unique sequence, order by start time. Okay, let's run this query. See, I'll run the previous query. So see, this is the final output, and this is the original data. So now it has what we say, it has aggregated the logs which are having same state in a sequence, start time, end time. Okay, this is the output. So basically there is a really complex query we are using, so I have made it small for the representation. So now we are also checking exemptions, like whether suppose driver is on duty, but there is some problem, adverse weather is there, so he can opt for exemption, like we should not calculate those hours in his work time, like, because we can say that we can accept this so all these conditions we are handling. So it has become really complex. If you see that query, so this is the original query which we are using. Exemption rules, we are using set exemptions and date. So that's it from my side. So do you have any questions?
Assuming the use case was basically we have time blocks in our database, and we want to find out the productive time. So
Right.
Right.
We want to group the similar records to have, like, this is a raw data, and we are extracting information from it. Yeah.
So I don't work in Postgres.
Okay.
In Mongo, the way that we do is there is something called aggregation pipeline.
Okay.
So what aggregation pipeline allows us to do is it allows us to write stages. Stages can be it can be a group by stage, it could be a project stage, it could be a find stage. So I think in that case I would have done is I would have written a find query. So find query is nothing but getting all of your records for let's say a particular driver. Second stage would be your project stage. That what I would have done is for now project stage is actually across every match entry. So with the first stage I written a match criteria, right? So I get all the rows for that driver for that time period.
Okay.
For that day. In the project stage, what I'll do is I'll project a new value from those match records. So what I've done is for every type of state, I would have projected a value. That would be for on state. I'll always take difference between end time and start time because I have records. Right? So for every on record, I'll take the sum and I'll add that. So what I'll have is eventually for start on state, I'll have the sum of all times
Okay.
on for sleeping, the time you are sleeping, for probably I don't know this off. So for that I'll have the right. And next I can then group by for that period. So
Okay. All this is done in the Mongo script, or
so
okay.
basically just write a Mongo pipeline in your whatever driver you want. Pipeline goes into your Mongo executes it.
Okay.
Across nodes and whatever strategy you have implemented. So that is the way I would have handled in Mongo.
Okay.
Another way is, I can think of this is since storing raw raw records, I think the other probably use case was to have some exemptions, right? So for probably let's say a specific type of record, now we have exemption that we want to exclude. This record should be excluded. So probably what if we could have just created another table out of this that can be merged the records. So we just update the row instead of having raw records, we'll have merged rows. So that if the on state is there and again the on state record comes, I'll just update the end time of that record. So I'll automatically have that synchron the states that we want.
Okay.
So I mean, can't we use that?
Actually, I missed this thing. So we running this query every time for each API request is expensive. So what we are doing is we have created another table aggregated records, and what we are doing is we receive a batch of records when we get the ELD logs, like these ELD logs for transactions logs. So whenever we get the transaction logs, in the background we process that and we aggregate, and if it is updated, if we need to update the previous record, if we need to create record, we take a decision and we store that logs in that table. Right. Yeah. And there is a business use case for both the tables. So we cannot delete these records and only keep that aggregated records.
Because I think since you have added virtual columns, right? I don't know, but I think write query will be heavy, right?
Yes.
You have to create all those records
Yes.
every time a record is issued.
Yes. We are not saving that virtual columns anywhere.
Yeah.
Yeah. Yes.
Oh, so you are not saving.
Not saving.
Query time will
Yes, it is generated on the go, and it is used in that query only.
Why query is related, then only there.
Yes.
But if you then need to query this a lot of times, why don't you just add it as a columns directly? Help you to read. I mean, obviously depends on the use case.
Yeah. Actually, that table is too much populated right now, and adding another columns also that migration also takes 2-3 hours or 4-5 hours. Yeah, that aggregated logs is fine for us. Okay. Any other questions? Thank you.